Okay, so in our last example of 1D motion problems, I want to do a velocity versus time graph analysis instead of just a computational problem. So we have a wildlife biologist that is studying the hunting pattern of tigers. She anesthetizes a tiger and attaches a GPS collar to track its movements. The collar transmits data on the tiger's position and velocity. The figure shows the tiger's velocity as a function of time as it moves on a one-dimensional path. So we have to keep in mind here that what we're dealing with is a velocity graph. So this is not the path of the tiger. These are just measurements of the tiger's speed or velocity specifically at different points. So question 1 says, at what point or points is the tiger not moving? Well, the tiger is not moving if the velocity is 0. If the tiger's speed and velocity is 0, then it's standing still. And we can see that at points A, E, and H, we have 0 velocity right here on our velocity graph. So this is answered by points A, E, and H. The next question says, at what point or points is the tiger not accelerating? And so acceleration is something other than what we're given in the graph. This is a velocity graph, but we're asked about acceleration. So we have to recall that acceleration is the instantaneous rate of change of the velocity, or the slope of the tangent line from calculus. So if we look at the tangent lines to all of these points, we have an end point here, but we can kind of guesstimate the tangent line looks something like that. That has a positive slope. So its acceleration is going to be positive, not 0 like we want. So let's look at point B. At point B, we also have a positive slope, but here at point C, we have this horizontal slope. There's an arc here in our velocity graph. So the tiger is speeding up and then he's slowing down. So our horizontal tangent line, our instantaneous rate of change of velocity, is 0. There's a point where he stops speeding up and he starts slowing down, and right at that point his acceleration is 0. So that's point C that we know of. Now point D, tangent line is about like this. That's a steep negative slope, so that's definitely not 0. At point E, looks something like this. That's also negative and non-zero. But at F, we have another horizontal tangent. So at point F, we're also going to get a 0 acceleration. And then at G, we're back up to accelerating positively. And H, and even though it's an endpoint, we can kind of extrapolate and guesstimate that that's what the tangent line would look like if this graph kept going smoothly. So we have C and F are our horizontal tangent points, and since we're looking at a velocity graph, that means we have 0 acceleration at those points. Okay, the next one says, at what point does the tiger have the greatest speed? So if we're looking at speed, speed is just the magnitude, speed is just the magnitude of the velocity. So we have to be careful here. It would be easy to say, oh, well, the biggest value is right here at C. That's the highest value. In this case, it happens to be right, but if we had some point that was maybe this graph went in a different direction, and we had some point down here. Well, the distance from this new point to 0 is greater than the distance from C to 0. So if we were just looking at speed, the magnitude of the velocity, or the speed at this point, would be greater than it is at C. But in this case, the lowest point on our graph is here at F, and this distance here is obviously smaller than this distance here. So our greatest speed is at point C. Next question says, at what point does the tiger's acceleration have the greatest magnitude? So again, we're asked about acceleration, which is the slope of the tangent line of a velocity graph. And the steepest tangent line is going to be right here. It's going to be that tangent line right there. I'm going to get a better picture. So it looks about like that. Even though it's negative, it's going to have a large negative value, the slope of that line right there. The magnitude of it is going to be greater than any other line. None of our other slope lines that we drew earlier were quite as steep as this one. So that's going to be at point D. Next question, and the last one, says at what point is the tiger farthest from its starting point at t equals 0? Again, it's easy, your brain might just immediately say, oh, we're right there at C, but remember, this is a velocity graph, not a position graph. So we start here at 0, and anytime we're above the axis here, this is all positive space up here. This is positive velocity. So all of these points on the graph here mean that the tiger is moving forward and away from his original position. So it's not that the tiger went and then started backtracking. The tiger is moving away from his position all the way up to E, and then the tiger starts moving backwards again to the point H, the time interval from E to H. But the greatest distance away would have to be at E. He's moving away at a positive speed from his starting point all the way from A to E, and then he starts to back up just a little bit. But his farthest point away is going to have to be at E when he had a positive velocity. Or excuse me, at E the velocity is 0. All up until E he had a positive velocity and so was moving away. So this is the point E.